Hello, ladies and gentlemen. I hope everyone is doing well today. Today we are taking a look at forming ions. It is the first Chemquest found in our Unit 7 bonding units. So to start, we have some information on ions. So we have a few Bohr diagrams that we're going to look at as I adjust my camera. So we have an atom A, and then we have an ion of atom A. So remember, we don't know what atom it is yet, but we do know that they are the same. Same thing down here. We have atom B, an ion of atom B. One thing worth mentioning is I did not do a great job of drawing, moving my electrons around. So there is one that is not on the ring, so cross it out and add it onto the outer energy level right next to it. So we start down below with question 1. Question 1 is proving that atom A and atom B are neutral. So remember, atoms are over here. Remember having a charge of 0. So if you forget how to do this, compare the protons to the electrons. What do you notice? Next we can figure out the identity of the atoms. Remember, we have the protons given to us, and then remember that the atomic number equals the number of protons, and it equals the number of electrons in an atom. So remember, it only equals the number of electrons when it's in an atom. So we are starting to deal with ions now, so be careful. Make sure you see the word atom if you're going to use atomic number equals protons equals electrons. And then lastly, down below, question 3, how does an atom become an ion? So use these pictures to help you. So compare the electrons between the atoms and the ions. So what do you notice the difference between atom A and ion A? What's the difference between atom B and ion B? So make sure you take a look at both atoms. They do something similar, but it is slightly different. So make sure you take into account both atom A and ion A, and atom B and ion B. Next, we have question 4. So question 4 is now figuring out the charge. Remember, when you have a charge, you must have the sign and the number. Remember, we call the number the magnitude. The magnitude is just the value of the number. So you can do this two ways. You can compare the protons to the electrons, or you can use the formula charge equals protons minus electrons. So this is review. So you will be able to check your answers when you're in class. So I'm not going to take some time and go through it. Question 5. So question 5 is now figuring out how many electrons does ion A have. So you can simply do that by going back to the ion and counting up the electrons. So we can do that quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it has 10 electrons. So then next it's asking about an atom. So what atom has the same number of electrons as ion A? So ion A has 10 electrons. So remember, because we have the word atom, we can use the relationship atomic number equals the number of protons equals the number of electrons. So we come over to our periodic table. Which atom has 10 electrons? It's neon. So then we write neon. 6A and B are very similar to 5A and B, so mimic that question how I did 5. Next, question 7. Question 7 says bromine atoms always gain 1 electron when they become an ion. So don't worry about that. We'll figure out why in a little bit. Which atom has the same number of electrons as a bromine ion? So we can go to our periodic table again. I find bromine on the periodic table. It says it gains 1 electron. So if it gains 1 electron, we move 1 to the right. So it's going to look like krypton, number 36. Number 8 is very similar to number 7, except this time, instead of looking at bromine, you're going to look at cesium. Cesium has an atomic number of 55, so that should help you find it a little bit faster. And then remember, this time it is losing an electron instead of gaining. Question 9. So question 9, when you think about question 9, you should notice something similar about all of the atoms that you figured out between 5 and 8. If you can't figure it out, think about what column are they in, and then what do we call elements that are in those columns. Question 10 also relates to question 9. So why do you think all of the atoms we've been working with form into ions in that column? What do we know about that column? Why does every atom want to act like that? Alright, so the next page, the last page. So as you guys can tell, there is a lot of important information in this top paragraph. So hopefully, as you've been working through this packet, you remember that the definition of an ion from earlier in the year, ions are the same element, but we have different number of electrons. So one of the things that it reminds you up here is all of the noble gases are very, very stable. Remember guys, noble gases are found in column 18. Everything in column 18 also has 8 valence electrons. Remember, having 8 valence electrons makes them stable because the outer shell, the valence shell, can only hold 8 electrons. Because it's full, that means it's stable. It doesn't mean it wants to gain any more electrons. It doesn't want to lose any electrons because it has the maximum amount. The next thing I want to focus on is this, the next sentence. So ions form in a way that they will have the same electrons as a noble gas. Remember, they do that because it makes them stable. So you might want to go back now and you can check your answers to question 9 and 10. I just talked about some information that might help you answer those if you were struggling. So next, the paragraph uses oxygen as an example. So I drew a Bohr diagram of oxygen up here. So in the center we have our 8 protons or 8 neutrons, and then what we're going to focus on, because we're dealing with ions, we're going to focus on the electrons. There are also 8 electrons. So remember, it wants to act like a noble gas because that makes it stable. So we can look back at our periodic table. So oxygen can look like a noble gas if it gains 2 electrons, so 1, 2, or it also has the option to lose 6 electrons to look like helium. So it can go 1, 2, 3, 4, 5, 6. Oh, now I got to slide back over. That is the equivalent of losing electrons. Remember, helium is still a noble gas. It's the only exception because it's part of the s block. So that means its valence shell is full when only it has 2 electrons. So remember, helium is still a noble gas. It's still very, very stable. So we now know that oxygen can either gain 2 electrons to have a full valence shell, or it can lose 1, 2, 3, 4, 5, 6. And if we remove that shell, then the shell lower is full. That makes it stable. So as a general rule of thumb, it's bolded. It's easier just to gain or lose the fewest number possible. So it's easier to gain 2 than lose 6. So when oxygen becomes an ion, it will gain 2 electrons. So that will help you with 11 and 12. When you're thinking about the charge in number 12, what is the charge of an electron? And if we gain 2 of them, how would that affect the charge? Question 13. Question 13, so now we have a few examples. It wants us to figure out if atoms will gain or lose electrons. So to do these, I like to use my periodic table. So we come over here, and I'll cover the bottom, but I will leave the question that I'm working on A. So consider an aluminum atom. To become like argon, would aluminum have to gain or lose electrons, and how many? So we come over here to aluminum. Argon is over here on this side. So it would have to gain 1, 2, 3, 4, 5. It would need to gain 5 electrons. So then we can go to the next part. If we look at aluminum, part B. To become like neon, which is number 10 over here, would it have to gain electrons or lose electrons, and how many? So we come over here to aluminum. So I'm going to slide the periodic table as I do this so we can see the other side. So it would go 1, 2, 3. And then we're back to neon on this side when we hit 3. So that means it would need to lose 3 electrons. So considering our answers, what would aluminum do to become an ion? Well, remember guys, as a general rule, atoms will gain or lose the fewest number of electrons possible. So because of that, 3 is less than 5, so it will gain, it will lose 3 electrons. So aluminum will lose 3 electrons. So now we can think about the charge of an aluminum ion. So remember, electrons are negative. So I kind of wrote it down on the wrong spot, I guess. I just had more room over here. So electrons are negative. So remember, if you gain electrons, then it will become more negative because electrons are negative, so you're gaining something that's negative. If you lose electrons, then it becomes positive because you're taking away something that's negative, so you're left with what's positive. So what that means is if aluminum's losing 3 electrons, it will become positive. Because you're taking 3 away, what it would become would be positive 3. So next we have question 14. So question 14 just wants us to do what we just did for aluminum for a few other elements. So I'll help you with the first one or two, and then you guys will have to finish the rest. So the first example is calcium. So we come over to calcium on our periodic table. So we need to figure out, will it gain electrons or lose electrons? So if we check out calcium on our periodic table, look, it would lose electrons, because if we lose 1, 2, we would be back in argon. We know that to look like a different noble gas, it would have to gain all of these electrons, which is just way more than 2. So we know that it's going to lose 2 electrons, which then means if we're losing 2 electrons, if we lose electrons, it becomes positive. And then because we're losing 2, it would become positive 2. We can next do the same thing for chlorine. Chlorine is on this side of our periodic table. So it's the same kind of thing. Chlorine is right next to argon, so that means you'd have to gain 1 to go to argon, or you would have to lose all of these to look like neon. 1 is definitely less than all of these, so we know we're going to gain 1 electron. So we'll write gain 1 electron. Remember, when we gain electrons, it becomes negative. Because we're gaining 1 electron, it will become a negative 1. Remember, however many electrons you are gaining, that becomes the number, the magnitude of the charge. Like always, guys, if you have any questions, please circle them, write down your question, and I'll answer them in class. Like always, I will try to end these with a joke. So, what's the last thing through a bug's mind before he hits the windshield? His butt! Well, I hope everyone has a wonderful day. I'll see you next class. Bye.